Hey everyone! Thank you so much for watching another episode of the Weaviate Podcast. I'm super excited to welcome Rose Wang. Rose is a Ph.D. student at Stanford University, where she's doing amazing work at the cutting edge of AI applications in education. I mean, education and AI is such an exciting thing. I know personally I'm using it all the time to learn anything. And Rose has recently led a study titled Tutor CoPilot, one of the world's largest randomized control trials, all sorts of amazing details behind this. 900 students, 1,800 tutors, K through 12 students. So really just one of the most comprehensive studies on really understanding the impact of AI on education. Rose has also published so many amazing works at this intersection of human learning, AI learning. What can we learn about how to make AI learn from how humans learn and vice versa? Things like curriculum learning and backtracing. I'm so excited to dive into all these things. Rose, thank you so much for joining the podcast.
Yeah, thank you so much for having me.
Awesome. So I love kicking it off with this question about just sort of like what led you to this particular area of study of AI and education.
Yeah, thinking back, I think I've always been really drawn to like extremely real world complex problems. And I felt like in education, you kind of just start to see the full stack of like real world complexity. I think for context, I feel like most of us, we don't actually understand how difficulty teaching is because most of us experience it as from the front stage as like students receiving, the way that teachers teach in the classroom or how like teachers are performing their um, as they're teaching. But I feel like through the PhD, I've been able to kind of unravel or go through all the layers of the onion, peeling back to this full stack of, what gets actually the teacher into the classroom teaching effectively. It incorporates so many things related to like, the kind of curriculum that they're supposed to be teaching in that school district. It's related to like the kinds of tests they know that they have to get students prepared to by the end of the school year or by the middle of the school year. Then all the lesson planning, the day before things, before they actually come and perform in front of students to actually get them to learn. And I think just being able to like see a lot of that complexity and appreciate it, and then starting to realize like, wow, there's a lot of online reasoning, a lot of planning that they have to do right when they get into lab interactions. Like that's something I really want to understand a little bit more. And teaching and learning just felt so intrinsic to like understanding this kind of exciting boundary between like natural and artificial intelligence. So I felt like it was the right place to kind of explore all these questions.
Yeah, I love these algorithms for AI learning that are sort of inspired by human learning. Like as I mentioned, curriculum learning. That's one of my favorite ones because it's so intuitive that the training data should be presented in a way that first you learn how to add before you learn how to do something else. So I really love anytime you can derive it from that. So yeah, I think maybe even before diving further into just this amazing opportunity of AI for education, I'd love to understand Tutor CoPilot further. I think when I first read the paper headline, I saw the scale of it had just really blew my mind. So could you just explain how you put this together, all the things behind it?
Yeah, definitely. I think like, well, first, like thinking a little bit about the scale is like, education is a huge operation that like all societies just have to figure out like how to be able to robustly deliver at scale and also at high quality. And I feel like the reality of today is that in order to deliver this at high quality, we kind of have two extremes. One is, we rely on human experienced teachers to be able to teach these kids, but also be able to teach like the future of teachers, right? Like these novices. But unfortunately, human experts are really hard to access. Like they're very expensive, they're very limited, and hence, it's hard to just scale that form of high quality education. And as you'd mentioned, like we're really at this exciting time where now we have this other extreme of automated teaching, so with language models. But we've already been seeing like some early evidence where it doesn't seem like we can exactly rely on models to be able to do the entire teaching process end to end. It's tricky to get the interactions right reliably, and especially when you start working with younger students, it oftentimes in order for them to actually learn, the burden kind of falls on them about how they interact with the model. Like, do they want to really struggle or do they really want to like just get the answer from the model? And oftentimes that's really tricky with young students because they don't really know how they should even be learning. It's kind of like asking a patient to like lead the conversation with the doctor. Like the patient has to figure out everything they should be doing in that situation, when the reality is that we do rely on experts or humans like, the doctors and the teachers to be able to lead those kinds of interactions. So Tutor CoPilot was kind of a vision and then turned into reality of getting the best of both worlds, where you get to keep and augment the human with AI, where it kind of, realizes this idea of like every person, whether it's a novice in education or in healthcare, they can be empowered with real-time expertise. And what's really exciting is that with this vision, you're enabling novices to act at an expert level, and simultaneously provide students with high quality interactions that typically only a seasoned teacher could really offer. Yeah.
Hmm. Yeah, I think one thing I want to dive into then is you mentioned like the I think one parallel here is you don't know what question to ask, is like kind of like that unknown thing with learning, and that's why I think maybe like stepping out a bit is this podcast. I think something that's interesting about this is sort of like we're two AI experts, so to say, and we come up with questions to ask each other that maybe if you're writing a transcript to ask, say, Google's NotebookLM, it might not come up with that particular question. So that kind of aspect of it. But I really want to zone in on this like categories of learning. Like in Tutor CoPilot, you have these strategies. So
Mhm.
yeah, so maybe if you could zone in more on like the categories of how you teach someone something. Yeah.
Yeah, no, that's a great question. So the work that kind of preceded Tutor CoPilot is the reason why we have those strategies in the Tutor CoPilot interface. So what happened before, prior to Tutor CoPilot, was that it was in a previous work that was called like Bridging the Novice Expert Gap. And in that work, what I was really interested in was basically, how do you get a language model to generate something similar that sounds like an expert? But what I realized was that, if we go through the traditional way of being able to train a language model, like collecting a high quality, well curated data set of, let's say, conversational context with responses written by an expert, and you try to, use these data sets in ways to adapt the language model, like doing in context learning or fine tuning, it was actually really tricky to get the model to like generate responses that made sense and like were felt, like that they were coming from an expert. Like they would get surface level details right, like asking a question, but then you read the question and it was like kind of repeated the mistake that like the student was already making, so not really pushing the conversation forward. And so what happened was that, this kind of realization went from the previous work, was actually realizing that what we were missing was that experts do a lot of inference work when they're doing these interactions. So there's a lot of thinking that goes on that we don't typically observe, because all that's kind of packed in their head. And so in the previous work, what I had done was I worked with experts and I asked them to basically talk out loud as they were writing their final responses that we collect in the data set. But over time, as you keep collecting more and more talk out loud transcripts from these experts, you start to realize that there's like very consistent reasoning patterns for how they think about how they want to tutor students, because they've seen a lot of students in their past. So like, what are they kind of recalling or retrieving from their past to know what seems to be really effective for teaching different kinds of mistakes, and like, so what kind of strategies came up. And so from that work, we had curated as actually a set of strategies that real experienced teachers do use in their day-to-day teaching experiences. And those are actually now the strategies that you're seeing incorporated in Tutor CoPilot. So it's really trying to mimic the way that, or model the way that experienced teachers think. So not only seeing the actual responses, but like under the hood, like what were they trying to do?
Amazing. This is honing into maybe I think there's kind of two things here that I really want to dive into more. There's the talking out loud. I love that chain of thought, adding a rationale to sort of like every task we're using deep learning for now. It's sort of like it has this interpretability. I think there's a new paper from Apple that's kind of saying like, hey, they're not actually reasoning, so maybe I shouldn't jump to saying it's definitely the rationale behind it. But um,
Yeah.
actually, really, what I want to zone into is this parsing through these rationales to come up with the strategies. I think that's just so amazing. You in the paper you describe how you classify like 550,000 chat messages. And at Weaviate, we're working on something called generative feedback loops, which is basically we're trying to build a service around this exact idea of like a data set of like 500,000 or however many, and now you're trying to do inference over all of them. Could we dive into just, I guess even first, even before the like, how do you curate the strategies automatically from these rationales? I'm just curious, like, how do you run 500,000 inferences? What kind of things did you learn about?
Yeah, I think so. From the development process in the previous work, what had happened was that I mentioned, we collected this kind of talk out loud data, and if you actually transcribe it, you just start to get like really, really, really long pieces of text that oftentimes also felt a little bit unstructured or hard to parse through. And so, but the nice thing was that, like, as you start to collect many different examples or many different transcripts, there does appear like commonalities or common structures of how teachers start to reason. And so what happened was that, taking those kinds of transcripts, we can start to distill maybe common features. So like, oh, like noticing that teachers are first trying to figure out like what the student doesn't get, or just from the very minimal evidence of like what the student says, like, oh, they just say the answer is 5, but it's wrong. So like, but what does their answer maybe suggest about what they don't understand, to then figuring out like, okay, what kind of strategy and where do I want to get this student to? So part of that was like from a very ground up approach of like, let me just kind of collect really raw data, distill it into something that's more structured and more coherent that I can actually use to instruct a model to better understand and model or like follow. Um, and then when we had actually deployed Tutor CoPilot, and as you mentioned, collected like just so many different examples of how like interactions look like, a lot of that was kind of blending together the emergent strategies that we had found from the ground up, as well as complementing it with like existing like high level taxonomies that people say like, oh, experienced teachers do this, like they ask questions, but really trying to like ground that high level description to something that we actually see in the data as evidence. Like, what is actually a good question? We don't want to identify questions that are just like, hey student, are you there? But we want questions like, oh, what do you feel like belongs in the middle of these two numbers that we're thinking about? um, so a lot of iterations between both like more higher level theories of like, what good or bad feedback looks like, to then a really grounded approach of like, okay, in practice, what are people actually doing? What's in our data?
I mean, so you have this taxonomy of is like teaching strategies where you've sort of inferred some model of the student's understanding, and then so say you have like 10 or so categories of this one. Sorry, I missed that detail from the paper.
Very good. Yeah.
But yeah, so you start with this taxonomy, and then by going through classifying it, you're refining your understanding of the category from the data that
Yeah, exactly. And I think that in practice is what happens a lot in a lot of the projects I've done, because I think especially as so also for context, in a lot of my PhD, it's been working with a bunch of different kinds of learning interactions, whether it's like one-on-one tutoring, which is what Tutor CoPilot was, to then a teacher with like 30, 40 kids simultaneously. And so when you take like a high level description, like asking a good question, that kind of question will look really different, whether it's in the classroom versus like in a one-on-one tutoring setting. And so a lot of this work has been like, how do you kind of identify these really good strategies at scale? But in practice, we have to collect a representative data set, and we might have to also refine these kinds of categories as we're actually looking through the data. So and it's kind of trying to go like iterate between these two ends of like mapping things that we actually care about to actually things that we're collecting and seeing, and informing the way that these interactions are happening, and what seems to be less effective, what seems to be more effective.
Well, I guess like on one hand, I'm just thinking about how this is just a new approach to classification, I think. And I think classification is just one of the most well-studied problems in machine learning. But now that we're using these generative models to uh, you have some labels, or you have feature, and I'm also sort of this like difference between features and then classes. So it could be like
Yeah.
features also, but like now you're refining your understanding of the features from your data set and then doing it at scale with these large studies. That one I think is just so powerful. But so now I'm thinking about this. It's really making me think about sort of the reinforcement learning problem of the tutor and the tutor CoPilot, where the CoPilot is kind of like saying, here's what action I think we should take, right? With the like, here's the kind of question I think we should ask the student next, right?
Yeah, in Tutor CoPilot right now, we're not doing anything smart about the strategy recommendations. So as you were suggesting, right, like maybe there's something historically really interesting about how tutoring should be conducted for the specific student, or maybe for this specific tutor style. I think it's definitely something that would be really interesting to explore. Like I've looked a little bit into, let's say, I guess also related to understanding usage of Tutor CoPilot has been whether or not the tutors actually just copy and paste the suggestions, or whether they're adapting the suggestions or getting inspired from it. I think this really kind of opens this whole can of worms of like human AI interaction, like how seamless is it, or what does that usage look like? What does that mean for like how novices are learning? I think in practice, what I'm seeing is that a lot of tutors, there's a lot of like creative uses of how they're looking at suggestions. So I've definitely seen ones where they don't immediately take on what the tutor CoPilot suggested, but they'll like break down the concept that CoPilot is kind of like sketching out for them. And so that's also another place where you can imagine um, deriving these kinds of reward functions to be able to learn like what's good behavior, or like what would actually be really useful to generate in these kinds of interactions. Yeah.
Yeah, I love that, the human AI interaction, building these new interfaces. I think if I have to do like this whole history, but obviously there's ChatGPT, and then I think we had Cloud Artifacts, and then Stanford had Storm, which is something I really liked, and then
Yeah.
the Google Notebook LM. And yes, I guess I want to just ask you broadly about this human AI interaction, and just sort of like what the phrase inspires you to think about, and yeah.
Yeah, I think just it's been so exciting to just see so many iterative versions of what seamless human AI interactions look like, because this is now finally a state where AI systems don't feel like this abstract thing that we talk about in papers, but rather there's interfaces. There's like, product facing things that we can try out. Um, I feel like one thing that's been really exciting is just like even if we look back on like a really brief history of things that have emerged since ChatGPT, right? We had ChatGPT and Storm that felt like they're really the initial use cases were always about like one shot almost content generation, right? Like you give it a prompt, you ask it to generate an essay, or you ask it to generate a poem or an article with a particular topic or with a particular style, and we just see like, wow, like now we can generate just massive amounts of text and content. And now what's really interesting is that like as we're getting really coherent AI models and we're getting used to the way that they behave, we're starting to have like real opinions about like how our interaction should look like, right? Like we don't now would I don't want to just generate long contents. Like I actually want to be able to like maybe like be able to cache the content later on for future use, or be able to reuse it not beyond my current interaction. So this gets into like Claude artifacts. Like I want to be able to re-reference content from the past. And other things I think I recently were seeing was like OpenAI Canvas, right? Like now when we're editing, I don't just care about macro level changes, but also micro level changes as well. The cool thing about Tutor CoPilot that's a little bit different from these previous like human AI examples is that Tutor CoPilot is immediately integrated into like an ecosystem where real tutoring happens. And there's like kind of a high stakes component to it. So like tutors aren't switching back and forth between like tutoring the student and then consulting like chat GPT on the side,
Mhm.
but rather everything is integrated just immediately as they're interacting with the student. Like Tutor CoPilot has access to what the tutor and the student have already been talking about. So they know about the lesson topic. And that's not something that I think in these previous interfaces that was really possible. Like it's a separate interface, right? Storm has its own interface and ChatGPT has its own thing and Claude has its own thing. And you're kind of really missing this like kind of seamless integration. And so That's been one thing that I've been really excited in doing in Tutor CoPilot is like, how do you immerse this in this really naturalistic ecosystem where people are already interacting with, and how do you enable that like powerful augmentation real time?
Amazing. And it reminds me, I forgot to mention Cursor. Cursor is also really a fantastic one. And I think
Yeah,
exactly like you're saying, is so well integrated with the environment that you're using it in, that kind of autocomplete, and then having that for tutors. Yeah, because I think a lot about, even when I read your paper on backtracing, I kind of immediately map it to my world at Weaviate of like thinking about
yeah,
like debugging developer questions. And I think
yeah.
about this difference between, if someone has a question about how do I run Weaviate on AWS or something like that, and the difference between just asking that to a chatbot, or you have this Tutor CoPilot that's like, here are four different answers based on like my inferred theory of mine, because I don't think I've quite 100% understood. Like you have kind of like an inferred theory of mind of the question asker or the student as well, and then you also have this interaction effect of like these strategies of teaching, right? So there's kind of like two things going on with that.
Yeah, yeah, there's definitely kind of a lot of things going on in like this setting of, well, I'll just refer to as like the online reasoning setting, right? Like in the moment, what are you supposed to do? For Tutor Copilot right now, we're kind of letting the tutor do most of the inference related to like what's just harder to immediately observe beyond like in text. So like student misconceptions, which could be more like not directly observable in the immediate chat session, but could be observed like or inferred over time as the tutor and student are working more together. And what Tutor CoPilot's meant to do is like, yeah, generate a couple different suggestions for how to help the tutor think through like how do they want to conduct tutoring. Um, yeah. Mhm.
That's an amazing two kind of thing. I guess like with the world models thing, maybe the interface says, I think their state of mind could be one of these five things, and you have sort of this like toggle interface where you're like looking through different world models of like, oh, this is how they think you run things on AWS, or this might be how they think, and then yeah, that other thing of like how do you go about teaching people. Definitely a couple of really interesting ones. So I guess the next kind of question I wanted to ask about is sort of uh, the Tutor CoPilot as a tool for the AI tutor. So that is, like there's a lot of stuff about function calling and tool use and thinking about this kind of system as a tool for the AI as the tutor. I find that to be really interesting too. Yeah, I'd love to know what you think about that.
Yeah, I think that there's definitely a lot of variance in how you could use the idea of like extracting expert reasoning to either improve the ability of AI to be able to enable a lot of downstream applications, or like how you could use it to augment the experts. What's really exciting is, I guess, related to this idea of like, how do you take this really modular component that like captures maybe expert reasoning and enable all these downstream tasks. Is that the exciting thing is that like education has, and like many real world applications, has many like just really complex tasks out there. So regardless of how you use it, whether it's for grading or in this case like real-time interactions, I think that there's always something really exciting for it to enable, but also real challenges and opportunities to be able to still innovate, and figure out like what is the right way to solve this with technical methods, but then also realistically deploy this in practice and how you need to actually design these kinds of systems. So yeah, in this setting, it's really just like this AI component from this previous work that I mentioned, augmenting the novice. But I'm sure that there's also many other variants in which you can modularize that component and then use it for like downstream assessments or for grading, or for things like related to like lesson planning, things like that. So in previous works, with some collaborators, what we had done was take a similar approach or idea of understanding how experts think about lesson planning and then help them actually generate scaffolds that they can use in the classroom. And so that was also a really cool way of actually being able to understand, like, okay, the teachers know like what their students are struggling with. They know like the time constraints that they're facing and how their classrooms usually go. Maybe there's a disruption here and there. And so how am I able to kind of get my classroom to be warmed up or like generate this kind of scaffold that's easy to use, but also, ideally reduce the amount of time that teachers have to spend thinking from scratch about how to approach this problem. So yeah, just really excited about like the immense number of use cases or applications it can enable, but there are definitely still a lot of challenges that come up when going from theory to practice.
Yeah, well, I definitely want to come back to this, like, will the next sort of like, I think like Perplexity is sort of like one of the AI tools that I would say is maybe like the nearest neighbor to this, where it's sort of, but I don't even, because I think of like what like an AI powered Quizlet might look like, where it's not just trying to teach you something, it's also trying to develop like multiple choice quizzes or like short answer tests, and so it's like this whole new interface of interacting with AI. But something that I want to zone in further is like, I guess I've been so biased in thinking about personalized learning because this is how I use AI to learn things. It's just me and Perplexity, and we're like, hey, what's a Kubernetes namespace? But it's like, but this kind of like classroom of 30 people, that sounds like that must change it a lot. Maybe touching on the topic, OpenAI Swarm is like the most popular library right now, and this is like multi-agent. So yeah, if we could just talk more about, okay, it's not just teacher student now, it's teacher 30 students.
Yeah, no, I mean, I think this is a really fantastic point. Like, originally, before even doing like NLP or like AI in education, before I was really interested in just like these collaborative systems. So in particular, I had done like, I was really interested in multi-agent robots, like getting robots to collaborate with each other, or in undergrad I like created this simulation of or a version of like the Overcooked game where you're really interested in studying questions like how do we get humans and AI to collaborate on a game like cooking game setting. And I think that it's really interesting to think about like real world collaboration between humans and like how to best facilitate that. Like you had alluded to, it's a completely different ball game when we're now interacting with like 30 different students who have potentially many different concerns or many different problems when it comes to like understanding math. But a lot of that is also like there's an underlying like social dynamics that shouldn't be forgotten, right? There's like how do you facilitate good group talk in like different groups? And so some of the ongoing work that I've been doing is like looking at how teachers can best set up for small group work collaboration. Like, what do they do to be able to translate a really hard math task into one that students can best engage with and can talk about with their peers? Turns out to be a really non-trivial task because students will have different ability levels for understanding the task. Some of them might not, like, let's say one example was like, there's a math task about flying a kite, and some kids might not even have had experiences flying a kite. And so there's these other real world challenges of like just trying to contextualize problems that we're trying to get students to understand that will just come up in learning. And I feel like it wasn't something that I was able to really have when working on like robotics or like game settings because we kind of abstract away all these like real world challenges to actually getting collaboration to work in the real world. So I guess back to like a previous question, like that's also part of the reasons why I really appreciate this real world complexity of like, okay, if we really want good collaboration to like become reality, like what are the real challenges that we have to tackle? Like, let's not abstract that away.
Yeah, amazing. It just inspires so much. I remember with self-driving cars, there used to be the big thing that the reason they
Yeah,
can't work is because they won't figure out that sort of like, am I going or are you going? That kind of like
yeah,
debate.
exactly. Yeah, and I love that because it's like it really puts this like really ambitious vision into then realizing there's a whole long tail of real challenges that can lead to significant risks, but also in overcoming them, I think we're realizing like, yeah, the human component is really, really tricky to solve in these kinds of collaborative multi-agent settings.
Yeah, well, I guess there's like many AIs, one person, as well as like I could keep doing the many to many of that one, but yeah, and I love that you brought up that cooking game. That's a throw. I remember reading about that. Oh, that must have been like 3 years ago. That
Yeah,
one
yeah.
where, but yeah. So I guess. Yeah, it's also really this kind of like AI native applications is something we love at Weaviate, and that list of things like NotebookLM is something that's so AI native. It's generating a podcast for you, and now we're seeing this idea of having like 30 people together with like an AI teacher, and it's trying to make us collaborate. And I love zoning into on that, like how do we learn to collaborate? I had this one class when I was in high school that was like you had a discussion topic. It was like something like creatine. It was a biology class, and you were being graded on your participation in the discussion. This was like the test is how well you would participate in the discussion. And so maybe
Yeah.
things like that, like where we have I don't know if this is the future of these podcasts, even if there's like 15 people and we're all
Yeah.
together. Yeah, so maybe there's something there, and maybe that's another one of these new sort of AI native human AI interaction interfaces is something where you join a chat. Maybe it's like a Reddit, maybe it's like some kind of Reddit thing where you have
Yeah.
the topic and you just join, and then everyone talks, and maybe it's curated around that.
Yeah, yeah. I mean, I think that there's so many really interesting questions like related to, I guess I always think about like this kind of in between like natural intelligence and like artificial intelligence and like what is the right way to enable effective interactions. And especially when we look at settings like collaboration, we start to realize there's a lot of trickiness in managing those kinds of dynamics. But then also different pairs of like whether it's human to human or human AI. Um, I guess the other thing I kind of want to mention, since you had brought up also Notebook LM, and I was like reflecting a little bit about why the AI in education space has been really exciting, is that I think things like Notebook LM and like just the capabilities of current AI systems is that I hope that it's able to make a lot of things that previously weren't really fun to do more fun. And I think that's really important, especially when thinking about learning, because I think there's a lot of things in which learning, you just really have to struggle in order to be able to master content. And I think in particular, if you just think about math, like math is a really intimidating subject for many, many students out there. And um, it's really sad to see, if you're scared about math or you're just scared about people thinking that you're not good at math, that it limits you from wanting to try or wanting to do things. And I think with a lot of the recent things that have been coming out, when making like podcasts, I'm sure is like very, very hard to do, or there's many things like behind under the hood that like have to happen. And so if we're able to make that kind of interaction more fun, or maybe make math less intimidating, I'm hoping that students would overcome their fears and actually start to be okay with struggling with math, like not realizing that it's not them. Like there's nothing that they should fear about. It's just the process of learning is hard. And so that's one thing that I've been really excited about, like enabling better collaborations in the future, whether it's human to human or like AI augmenting human, or like AI directly interacting with like the student, and encouraging them to like really reach their full potential.
Yeah, I guess I have two things on that. More, I would go to the Notebook LM. Now it's so much fun to write something, right? Because
Yeah,
now you get to listen to a podcast about the thing you've just written,
yeah,
and
yeah, exactly. Yeah.
yeah, it's kind of like that too. Just with like when Cloud Sonnet first, I think they really were the first ones to get to that chat with PDF, and they were. I think that, there's a lot of open source projects on that, but they really made it so I write something and I drop it. I can't wait to see what it thinks about the thing I've written, and then with the math examples, I got this book on my bookshelf, The Joy of Abstraction, and the author talks a lot about like, do you want to learn math with examples or with math? Sort of like sometimes you're like with this category theory book, particularly, is like telling you about like equivalence relations, and you might need to say, hey, perplexity, like, could you motivate this for me? I need some motivation and all that kind of stuff. So
Yeah.
also, yeah.
Yeah, no, definitely. I think even just building on your example, we're starting to see that like, well, I think a lot of people in the math education world kind of already understood this before, but like being able to now like have our own experiences of like interacting with a system that's like just readily available, is like realizing that math or learning or anything would like involved in becoming an expert. There's not only just content knowledge about like do you know the basic principles of like what's entailed in algebra, or like do you know how to solve problems? But there's also things that are related to like your motivation or your engagement, or like the pedagogical means of like how somebody teaches it to you, or how somebody makes you feel as you're being taught. And I think a lot of these components really matter at the end of the day. It's not really just about content availability. Like we had that a lot in education before with like MOOCs. Like we just had so much content, but I think we kind of underestimated the importance of just like getting the real human to struggle and go through that content. We also saw versions of like, this interaction between content and like interaction when we were, in all virtual, right? Like during the pandemic, like we just didn't enjoy not being around other people as we were learning about content. And so it's really cool to kind of just see this like really special time that we're in to like resurface all the important factors that are also really important, which really just go beyond delivering contents per se.
Yeah, it's amazing. Yeah, I'd love to just know what you think about MOOCs and that whole idea as well. I think that like something to the other point of like learning in person. I had read this on like Twitter or somewhere, so it's not even a real study, but I had just read that it says you learn like 2 to 4 times faster when you're emotionally involved in something. And
Mm,
again, this isn't like
yeah,
I'm not really citing anything. I just like read this and
yeah,
decided
yeah.
it was true. But yeah, maybe we just what do you think? I guess it kind of comes to our other thing about new AI learning interfaces. But yeah, the massively online courses is this something that
Yeah.
interests you?
Yeah, I think the really cool thing about MOOCs, and also just maybe even regrounding it in the like today's new way of doing interaction and learning, is that like the tricky and cool thing about learning is that it requires a lot of time and requires a lot of investments on you as the students, or maybe you're like obligated to go to school, so maybe you already have that responsibility. The interesting thing about MOOCs, and maybe also drawing the parallel to like AI tutors, is that when interacting with MOOCs or an AI tutor, it really falls on you, the student, to be able to like commit yourself to like going through that content, or like when you're interacting with an AI model, that you're committing yourself to like really learning and struggling with the difficulty of that content. But similarly to MOOCs, like I can just close my tab on ChatGPT and just not learn. And so we are starting to see like, that again, like the importance of just having a human that's there, that's accountable for your learning, that keeps you motivated. Like many students when they were doing virtual learning, when I guess I'm particularly also thinking about younger students, is that like they just don't feel motivated when all day long they have to stare at a screen. And I think we as adults feel this, but in particular for young students who, maybe don't know how to carry that responsibility of leading that interaction or committing themselves to learning, it's really, really challenging. And so, kind of reminding us of like the history of interactions, that, that human factor is incredibly important, but there's always kind of space for being able to augment or reinvent the wheel when how do we improve the quality of those interactions that you have to go in day in, day out in order to be able to learn after a couple months or years.
Yeah, I think there's so much like the sort of the like I remember when with my education once it was like I could only study computer science. I was like, all right, now I'm having fun compared to I have to do all
Yeah,
these different topics and yeah, there's and then I think also the sort of AI ability to suggest the next topic to you, like you've kind of hit a dead end and you're like, all right, I'm bored of this, I'm gonna do something else.
yeah,
But AI can maybe
yeah.
break the wall. Yeah, awesome. So maybe sort of pivoting topics a bit, I really wanted to take some time to dive into your research on backtracing. I think this is such an interesting study about when you have a query, you're trying to find the source of what caused the query. And so I guess kind of my first question is just understanding how this differs from the typical information retrieval problem where you just, query most relevant document and just how it, yeah.
Yeah, so I guess, the cool thing about backtracing, right, is like, typically when we think about information retrieval, let's say on, Google search, I'll just take it as an example, is that we think about like a user query as, my search query that I'm gonna type into Google, and it's going to be used to, be able to retrieve relevant documents or websites, that presumably have answers to the question that I have. But in backtracing, we kind of flipped this setup around in that we're not using the query to find answers to that question. Like, a student's asking a question in their lecture and they don't understand some content. We're not trying to find necessarily the answer to that question, but rather like what had caused that question in the first place. And this goes back to also what you had mentioned about like generative feedback loops is that especially when we generate a lot of content, there and given a new query, it doesn't really mean that we have to generate even more content to be able to resolve the question or the answer, the student's question. It's like, how do we kind of go back and revise what we originally had? And I think we also had this, brief interaction about like how this is related also to like resolving code issues or GitHub issues. Is like, given a GitHub issue or like, i.e., the query, how do we kind of retrieve or identify the relevant parts of my code base that are kind of pertaining to the issue that we should now revise and update or address, things like that. And so, yeah, it just happened to be really grounded in this nice real world challenge and leveraging also maybe existing techniques, but also seeing like, oh, actually, our existing techniques are not quite there for being able to tackle this challenge.
Yeah, I think that's such an amazing person, and thank you for mentioning the generative feedback loops. I was really happy to hear that.
Yeah.
That idea of not necessarily generating new content, but refining what you already have. And there used to be a lot of work about, I think, knowledge conflicts. When people hear that now, they're probably thinking about like these RAG systems where the LLMs have some inherent knowledge as well as the retrieved context, and that's kind of what that's come to mean. But I think it used to mean you have this corpora, and you're trying to find like where the different documents might disagree with each other, perhaps, like if they're saying different things, and then it's like, well, who's got the evidence and that kind of thing. So I guess my question with you ask this question, you trace it back to the, say, the documentation where where it's telling you how to set up this thing, and then it's like, do you look at other questions that have been asked, like do you just update it based on this one inference, this one example?
Yeah, I think there's many ways in which you can do this. So one way, right, is given the query and then you're able to retrieve the trigger or the cause of that query, you can do an instance-wise update on that part of the content. The other thing that we had observed, which was what you had mentioned about like, looking at other queries, was that there were in fact a lot of similar questions that all were being traced back to the same part of the lecture or like in our domain. So I think there was one where it was funny. Like I think there was one place in the lecture where the lecturer or the professor had said something of like, okay, and then naturally the answer is going to be 5/4, and then immediately you just like if you go into like the queries that we had, were just like so many people asking about like, whoa, wait, what? How do we get 5/4? And so you can also use that as like really strong signal or evidence that that's probably a place where you would want to revise your content because it was not a very natural next step for in actually like teaching that content, yeah, and things like that.
Hmm. Oh wow. Yeah, that kind of like, how do we resolve all these questions, and maybe even that like with rationale, coming back to that, where we also
Yeah.
sort of try to add our predicted frame of mind for each of the
Yes, yeah,
questions.
exactly.
Yeah,
Yeah,
and
no, I think that's exactly it. Like, and maybe just like even take a step back. Like, I think the really interesting things about these interactions is like, yeah, what you had mentioned with like theory of mind or inference over other people that you don't typically observe, but you could just get like signals from, right, when doing backtracing, like seeing like, oh, a lot of people don't get that part, or even when thinking about like working with experts and like getting their reasoning for understanding why they're writing these kinds of responses. So it's been, yeah, really exciting to kind of straddle those two ends of like inference and then what do you do in practice.
yeah, amazing. So yeah, and yeah, just I thought that was an amazing paper. It's such a cool study, so I did want to just congratulate you on that one, as well as the Tutor CoPilot. And this is transitioning now into my next question. Coming back to Tutor CoPilot, is it just the study you put together, like 900 students, 1,800 tutors. I just want to ask, kind of like logistically, like what goes into putting this kind of thing together?
Yeah, great question. I feel like it was a lot of work. Yeah, I think, well, first of all, I think on a really high level, a lot of it required really good partnerships, right, with the tutoring provider and then also with the school district to be able to conduct that study. I think on the ground, there's, oh my gosh, like so many anecdotes and interesting stories that actually led up to the development of Tutor CoPilot, because the study itself is just 2 months, but I was working on this since like July 2023. So it like almost took 9 to 10 months to actually design the whole study, make sure that we were pulling the right kind of data, make sure that we were engineering and like tracking the right kind of things and design Tutor CoPilot, everything was functional. And then also getting like school district approval. Like I was supposed to fly out to the school district and January to like go and try to convince the school board to like
Wow.
approve of our study. But then it happened to be that my flight got completely canceled because there was terrible weather conditions that day. And so right before we had to like prepare one of our school district advocates to like just go in with like the most amount of information that they could have to be able to present this content. So it was a lot of like human to human operations of getting the tiny details right so that the actual intervention could be run. And I wish that there was like a better place to be able to talk a lot about these like human to human stories, because even though I think we're really excited about the AI part, I think we sometimes forget the amount of work it actually takes on the human side to actually enable it and bring it into the real world. But yeah, a lot of that work was just something that I'd really enjoyed doing. Like I think, yeah, just got me to better appreciate all the complex, nuanced details of bringing it to scale and, luckily also being able to really bring positive impact to not only the tutors, but also the students as well.
Yeah, and I guess I just want to like zone in on this because coming from Stanford and then doing this with this massive school district, and then it's like so I'm curious, and you have the positive result from the randomized control trial. I'm kind of just curious, like what's next? Are you going to go take over all of education? Like, how does it?
Yeah, well, I guess practically what's next is that right now I'm on the job market, so I need to figure out what are the right next steps. Both like I'm really interested in like in academia and also in industry. I think both have really interesting problems to tackle in their own kinds of ecosystems. So trying to figure that out. I think in practice right now in the short term, there's a lot of really interesting questions related to like real human reasoning. So we briefly talked, or we mentioned actually quite a few times, like the theory of mind stuff. And I think I've been really interested, like seeing whether or not LLMs can understand reasoning traces of humans. There's also things maybe mentioned a little bit about like the kinds of human AI interactions that were happening. So are tutors or novices getting inspired from what they're seeing from AI, or are they just like, completely depending on it and copying and pasting things? There's also some exciting other interventions that I've been thinking about, because Tutor CoPilot's really just focused on a specific skill. So it's like focused on how to help struggling students. But there's other things that are really important that we had mentioned, right? The socio-emotional learning, that kind of relationship building, the trust. And so how do you enable novices who are just maybe rarely strict about teaching content to like realize that's really important to get the student just like warmed up and ready to learn. So yeah, too many questions.
That's awesome. I mean, there's so many interesting things there. I guess like just a quick one I want to ask about is I'm very curious about this like I think Andre Karpathy has done a startup in this kind of education. I think as we had earlier been doing like our list of all these different human AI interactions, it seems very obvious that like some kind of tutoring experience is on the frontier. And so I guess I'm curious about this like commercial tool for that, like something like a Perplexity compared to sort of something that's like in the schools. Yeah.
Yeah, I think all of these things are not mutually exclusive. So, um, we can think about Perplexity as like maybe a tool that we can rely on, like when we're not in live interactions. Because I think when you're live and teaching, you almost feel like you have to, produce the next thing within the next few seconds. I don't know very much about Andre Kapathi's like startup in terms of like concretely what they've been thinking about doing. But from the really brief descriptives, I think I really like the way that he's described the like his view on teaching as thinking about it as like a full stack. Like there's so many different components to teaching that go beyond the live interactions that I've been really interested in. So related to, let's say, lesson planning, content curation, or like being able to give like real time like question answering kinds of settings. So I think I'd be really excited to see like what works well and like how to kind of compose it all together. It might also really depend on objectives too, because I think for the kinds of interventions that I've run recently in the past, we've always been really interested in like real world outcomes, and so working with the school districts and with the providers are really important because we know what these students are getting in their grades or standardized test scores. And those are really important signals for us to validate, like, are we on the right track? Um, so yeah, I think I'd be really excited to see like what comes next and how people think about these really complex problems as we, inject AI into the real world.
Amazing. This has really been just one of the most inspiring podcasts that we've done. So I mean, yeah, there's so much to it. Just, I mean, how we learn things is so obviously being completely transformed. I don't think anyone would be held out on that one. And then I love this kind of thinking about the future. Like, there's this research paper called The AI Scientist from Jeff Clune is one I remember, but I'll link it in the description of the video. But this kind of like AI is discovering new concepts, or even just like scientific literature mining, and then just like how do you then distill like something like the entire catalog at EMNLP or something to someone,
Yeah.
and just so many amazing things. Rose, thank you so much for joining the podcast. Learned so many things, and I'm so excited about all the work you're doing.
Yeah. Thank you so much for having me. This was really fun.